Let's have a look at a problem from calculus. So we're trying to find out the limit of this finite sequence given by this one over square root of n. So first thing, let's try and see if we can find a formula for this summand. So like I said, this n plus 2, so the bottom keeps increasing, the top keeps reducing. Right? If we use k, for example, I say, can I write Sn as 1 plus sum k goes from, I can say n plus 2, n minus 1. Right, the bottom keeps increasing until n plus k. Right? If k was 3, right, n plus up to n plus 3, then minus 2 would equal to minus 3 plus 1. I can say minus k plus 1. And the pattern is easily verifiable. I say k goes from 2, right? Because this term, right, k goes from 2, cannot go from 1. Up to 2n, so up to n in here. So right now this summand, like I said, can I just relate it to combinatorics? Because it looks like it's the way it's written. So when you have n minus 1, right, the top keeps reducing. N minus 2 down to n minus k plus 1. Right, the bottom keeps increasing up to n plus k. Now, since this one keeps reducing, right, maybe we can say this one keeps increasing. Right? Increasing, so n plus 1 all the way, 2n. Right? This one keeps increasing, so here I keep reducing. Can I say n plus 1 keep reducing n 1, 2. Right? So here, I say, like, keep reducing. Next one is n minus k minus 1 all the way down to 2, 1. Same thing. I just copy this one down. Right? So you notice that here, the top, right, reducing, 2n, reducing, keeps reducing all the way to here. So 2n factorial. Right, the bottom is what? n plus k keeps reducing. So n plus k factorial. Here, n minus k keeps reducing, so n minus k factorial. Right? So this is in fact combinatorics. 2n choose n plus k. Because according to the formula, right, this one supposed to be this one minus this one. Yeah, exactly, right? N minus k. So at the same time, my summand, I can denote it as A and k, right? You have n and k, right, determined by both of them. So how can I rewrite A and k? Right? So notice, right? So this should look familiar. Right? You have 2n keeps reducing, you stop at n, you don't all the way. So the n plus 1 factorial. So this is supposed to be 2n choose n plus 1. right? Because remember, right, not only can we write as 2n factorial over n plus 1 factorial times this minus that, so n minus 1 factorial. We can also write it as 2n times 2n minus 1 all the way down to, you stop at this minus this plus 1. You stop at n, and you divide by n plus 1 factorial, right, which is exactly equal to this one. Right? So really this is another combinatoric. Now I can just easily write down a and k. Right? It should be equal, the whole thing equal to this one. Right? Just this one divided by that one. Right? 2n choose n plus k divided by 2n choose n plus 1. So notice this one is a constant. Right? Maybe I can pull it out when I do this sum. Right? So 1 plus, right, just pull this one out. 1 over 2n choose n plus 1. So in the sum from 2 to n, now I can have this one. 2n choose n plus k. So luckily we found a closed explicit form for Sn. Now the question is that, can we perhaps simplify this sum? Right? So here we have a look at this. I say 2n choose 0, let's say, plus 2n choose 1, plus 2n choose 2, all the way. I say 2n choose n minus 1. How many terms in here? 0, 1, 2, all the way. So n minus 1 plus 1, n terms. Right. Here. Next term I say 2n choose n after this term. Then I say, okay, next term. Instead of writing here, I'm just writing backwards. Right, so next term should be 2n choose n plus 1. Right. So 2n choose, let's say, 2n minus 2. Right, the number here keeps reducing. Here, 2n choose 2n minus 1. 2n choose 2n. Right? So here, how many terms? N, 2n, n plus 1. This minus this one. Then plus 1. N terms. Right? This is one term. Right? So, in fact, this is equal to 1 plus 1 to the power of 2n. Right? The reason is that here we can say, okay, 1 to the power of 2n times 1 to the power of 0. 1 to the power of 2n minus 1 times 1 to the power of 1. So 1 plus 1 to the power of 2n here. Right? Power is 2n. Of course, we have 2n plus 1 many terms. Right? Except this one is the middle term. Then we have exactly n terms here, n terms there. The reason I write it backwards for these terms is that here we have symmetric. Like I said, they equal to each other. Because we have 2n minus this one equal to n plus 1. In other words, they add up to 2n. Or like I said, right? They add up to 2n. They should equal to each other. They add up to 2n. They should equal each other. Right? They equal to each other. And we single out this term. So you can rewrite it as 2n choose n, then plus. Like I said, each pair equal to each other. You have double of this. Right? Double. K goes from goes from what? N plus 1, N plus 2, all the way up. K goes from 1 all the way up to N. 2N choose N plus K. Now this time, almost looks the same as this one, except here we start from 2. There we start from 1. Right? So all we have to do is, remember, the whole thing equal to 2 to the power of 2n. Let's remember that. So copy it down, this one, single out the first term, right? To distribute 2. So first term would be 2n choose n plus 1. Distribute this 2 to the remaining sum. That's k from 2 to n. 2n choose n plus k. Right, this time should be nice and neat. Then we easily work out this one, right? So this time Sn should equal to 1 plus 1 over 2n choose n plus 1. We rewrite this sum into this minus this divided by 2. Right? Easy. Right? Over 2. So 2 to the 2n minus 2n choose n minus 2 times 2n choose n plus 1. So now can we simplify a little bit? Right, not all the terms, but just a few of them. Right, first term, perhaps not. I'll just copy it down. 2 to the 2n. 2 times 2n. Choose n plus 1. Right, second term, perhaps not. Minus. Perhaps I'll just give this 2 to here. So this 2 is gone, power reduced by 1. And here I just copy down 2n, n plus 1. Up there, 2n, choose n. Okay, the last term. This times this, yes. 2n choose n plus 1, they can cancel out. Negative 2 cancel, become negative 1. Right, but negative 1 and 1, they can just cancel. Right, so this time we have this. Now here we turned our Sn into this format. Like I said, I can simplify this one only. Right, 2n choose n over 2 times 2n choose n plus 1. Here we can just write everything down. So 2n factorial, n factorial, and this minus this, n factorial again. So what do we have in here? Right? So first of all, I say 2 times 2n factorial. Right? I just flip the bottom up. Right? I'm supposed to have n plus 1 factorial. Right? So this minus this factorial. Right? It's flipped. So this time, 2n factorial, they can cancel. Also, n plus 1 factorial, n factorial. Right, n plus 1 times n factorial, so n plus 1. And n factorial, n minus 1 factorial. So n times n minus 1 factorial. So we have n, and we have 2. So it becomes half plus 1 over 2. Right. So ultimately, this doesn't matter, because in the end, what we're trying to find the limit of Sn over square root of n. Right? Once you do that, you can 2 to the 2n minus 1 square root of n times 2n choose n plus 1. Right? You just minus 1 over 2 square root of n minus 1 over 2n times square root of n. So when it comes to n approaches infinity, right, these two terms will be gone. Right? All we have to do is focus on this one. Hopefully it'll have a limit. Okay, from now on it's just pure calculation. Right, we've already done the crucial step. So like I said, these two terms will be gone when n approaches infinity. So only focus on this term. Right? So when you write it down in details, right, square root of n times 2n factorial, n plus 1 factorial, this minus this, you have n minus 1 factorial. So when we see factorial, right, of course we think of using Stirling's formula. Right, Stirling, I say n factorial is n over e to the power n square root of 2 pi n. Right, n approaches infinity. Right. So both being infinitely large, they're of equivalence, meaning this divided by this will approach 1. So every time you see factorial, you can replace with this one, right? Under multiplication or division, not addition or subtraction. Okay, so here, right, if you have 2n factorial, just change n into 2n. Right? So maybe I can even write it as, so distribute the power. All right, so n to the n, e to the n. Let's use that, because we can cancel out many terms in here. So here, I say 2 to the 2n minus 1. And here you have square root of n times 2n, like I said. So first of all, you have e to the 2n, 2n to the 2n, square root of 2 pi 2n, so 4 pi, and right, that's your 2n factorial. Then n plus 1 factorial, e to the n plus 1, n plus 1 to the n plus 1. Okay, according to the formula. So square root of 2 pi n plus 1, e to the n minus 1, n minus 1 to the n minus 1 square root of 2 pi n minus 1. Okay? So that's the expression. Now, let's look at e to the 2n, e to the n plus 1, e to the n minus 1, right? Okay, so e to the power, so you have power of, and this will plus 2n, right? Here you have e to the 2n, right? So both of them are sitting at the bottom, right? So there's no more e's, right? No more e's. Right, copy down this one. Combine the square roots, all the square roots, right? Put them under, right? N times, so 4 pi n squared. Right, 4 pi n squared. Down here, that's 4 pi squared. N plus 1, n minus 1. All right, that's the, okay, square root 2 to the power, yep. No more e's. Copy down the rest. All right, so what's the remaining? 2n to the 2n. Right? N plus 1 to the n plus 1. N minus 1 to the n minus 1. Right? So this is what we have. So further, what do we have? Right? Maybe I can split 2 and n. Right? So it becomes 2 to the same power, then n to the same power. All right? So this and this, they can simplify. Right? 2 to the 2n, 2 to the 2n minus 1, 2 to the negative 1. Right? All right, that's half. Put the 2 down here, same thing. Right? Simplify this one. Right? Leading term is 4 pi n squared. Right? Down here, also leading term is degree of 2. Coefficient is 4 pi squared. Right? Ultimately, I say, don't worry. Right? Just focus on the coefficient. Right? 4 pi over 4 pi squared. You have 1 over pi. Right? Everything else is gone. Right? When it comes to, infinity. So, square root of 1 over pi. Right? The rest is, like I said, this one simplify. This one simplify with this one. So we still have n to the 2n. Right? So n to the 2n, like I said, I'm going to n to the 2n. So n to the n times n to the n. Still the same thing, right? N plus n. Right? Power is 2n. Down here, n plus 1, n plus 1. I say to the power of n, then multiply by n plus 1. Same thing. So this one, what happens to this one? Say n plus 1. Maybe n plus 1, n minus 1, n minus 1. n minus 1. I put the minus 1 here. So it comes down to calculate this limit. First, let me just flip this one, because it's 1 over this one. So all I have to focus is here. So initially it's 2 over square root of pi, right? So this time I say square root of pi over 2, right, flipped. And the rest is just down here. Right, 1 over something. Okay, here. Right, I'll group this one, group these two. Right, so what happens now is that I'm just gonna flip the blue, right? Because when I flip the blue, because we have 1 over that thing, right? So it becomes n plus 1 over n. We have the same power, that's n. And I'm not gonna flip the red. I'll keep the red. Keep it as 1 over that red. Right? N over n minus 1 to the n. Same power. Alright? Then the remaining is right? Right. So 1 over, maybe flip this one. N minus 1 to the power. Right, but that's just the reciprocal. Right, so ultimately, right, don't even worry about this one, right? Because this one approaches 1. Right, so when it comes to limits, right, so when you focus on this one, like I said, it becomes 1 over 1 plus 1 over n to the n. Okay? So this 1 over n minus 1 plus 1. Then n minus 1 cancel with this one. It becomes 1. Right, remember, minus 1 plus 1. Then you plus 1 over n minus 1 to the n this time. So maybe n minus 1, right? The same as this one. Then plus 1. But plus 1, I can multiply by 1 plus 1 over n minus 1. It's the same thing, right? So this time, immediately we notice that this one approaches E, right? This one. Right? We have the same consistent power and whatever that's down here, so right? So this one clearly approaches 1. Right? So ultimately, this is our limit.